evening. Thank you for coming this evening. You turn a light switch on and the light comes on. You adjust the thermostat, the house gets warmer or cooler inside. Refrigerators, stoves, microwaves, computers, digital cameras, things we take for granted every day. We've grown used to them, we've grown up with them. We don't know how they work, but they do. One thing they all have in common is electricity. When the electricity is there, things work great. When they don't, immediately we're on the phone to the power company. I want my power back. Electricity goes out, commerce stops. You can't make a sale, but we can't run a cash register. Crime goes up, the lights are out. So now it's time easy money. We'll rob somebody. All of them have one thing in common, that's electricity. The Energy Information Administration estimates that by 2025 we're going to need an additional 118,000 megawatts of electric generating power per day. Sounds like a big number, doesn't mean a whole lot to anybody. Basically it's 4 times additional California's draw. The power we already generate for the state of California, 4 more times we're going to have to increase in the next 15 years. 21 times what Minnesota uses. Simpler terms, the average power plant in the United States today generates about 1,000 megawatts of power. So we're going to have to add somewhere between 100 and 200 more plants in the next 16 years. Today I'd like to talk to you just a little bit about the most environmentally friendly, the most efficient, cost-effective means of doing that. Yeah, I'm going to use the N-word, nuclear. First, though, I think we should understand how electricity is developed. Basically, in 1831, Michael Faraday discovered electricity when he took a powerful magnet and moved it back and forth through a coil of wire and generated electric current. We still do that today. Other than solar panels, it's all the same. Moving a magnetic field through a coil of wire. It's just a matter of what power source we use to move that magnet. Whether it be hydroelectric from water, whether it be a wind generator, or most traditionally, we use coal, natural gas, or nuclear to superheat water, create steam, to turn a turbine that turns a generator. Those are the most efficient, the most effective ways, the ways we do most of it today. In the United States, there's 104 operating nuclear power plants that have been in operation for a little over 40 years. They generate about 16% of the power that we use here in the United States. Nuclear is the most efficient power source there is. The Energy Information Agency estimates 91% efficiency. Basically, if you have a 1,000 megawatt plant, you can feed the grid 910 megawatts. It's that efficient. Wind, that's the next most environmentally friendly, doesn't cause any natural disasters. The problem with wind energy is it's only 30% efficient. So to replace a plant the size of our nuclear plant here in Bridgman, Michigan, Cook Nuclear Facility, just 1/2 of that plant, 1,000 megawatts, would require 1,000 generators, 1,000 wind towers, covering 522 square miles. About 1¼ times the size of Porter County, just to replace 1/2 of one nuclear plant. It's not very effective, not very efficient. The other problem is it's inconsistent. Too much wind, no power. Not enough wind, no power. Well, I already grew up that way. In the 1950s, the big thing was off-peak meters for your major appliances, hot water heaters. We had an electric hot water heater, had a second meter outside the house, strictly for that. The electric hot water heater only ran at night when nobody else was using electricity. So Mom did laundry on Saturday. You either took a cold shower or didn't take a shower because there was no hot water. It didn't come on until overnight. I'm not ready to go back to that after all these years. Coal, natural gas generates about 80% of the power here in the United States. Not very efficient as well. The average 1,000 megawatt power plant burns 18 million pounds of coal per day. Again, big number, doesn't mean a whole lot. 18 million pounds is approximately 90 railroad cars of coal. Creates a train just short of a mile long. So every time you're sitting at a crossing for 10 minutes while a train goes by, that's over a mile long, that's full of coal for just one day in one power plant. It's not really efficient. Okay. Environmentally friendly, coal is definitely not environmentally friendly. It generates the carbon monoxide. In fact, 40% of all the carbon monoxide put into the atmosphere now is created for the purpose of generating electricity and heating for the public, according to Professor Avari in the Mechanical Engineering Journal, May of 2008. 10% of the coal is non-combustible. So we burn 18 million pounds a day. Now we have 1.8 million pounds, or about 10 railroad cars, of garbage waste that we have to get rid of, which of course is hazardous and toxic. According to Ray Harvey in the Mises Daily Report in February of 2009, nuclear energy could be virtually no waste. France has been doing it for 25 years. 95% of the spent fuel rod is natural uranium. You can put it right back in the ground just like you took it out. Basically 5% is concentrated uranium and plutonium. That can be recycled and used back to another power plant. Of course, we can't do that because in 1974, John McPhee wrote a book called The Curve of Binding Energy and scared President Jimmy Carter and everyone since then into the fact that someone may steal plutonium and make a bomb. So all of our waste is stored instead of being recycled and made useful. 40% of all the medicine in the United States and tests and treatments are nuclear in today's world. We have to import 100% of our radioisotopes for having our medicine because we can't reprocess and use our nuclear waste. Nuclear is also the most cost-effective. Nuclear energy costs about 2.8 cents per kilowatt hour to the consumer, according to the Federal Regulatory Commission's January 2008 electrical charts, electrical power generations. If here in the blue is the nuclear, is 2.8 cents. Natural gas and coal is 4.2 cents. Wind, solar, about 28 cents per kilowatt hour. Not very cost-efficient type of situations. In closing, basically, let's just run through some things. We need about 100 or 100 to 150 more plants in the next 15 years. Nuclear is the most efficient, 91% efficient versus 30% efficiency. 18 million pounds of coal per day in a coal plant. Basically 163 pounds of nuclear fuel to run one day in a power plant. A rock about the size of this podium. No carbon monoxide generation into the atmosphere. Virtually no waste if we're allowed to recycle it. No government subsidies. President Obama just initiated government loan guarantees to Southern Company from Georgia to build two new nuclear plants, the first in 35 years. I hope I've shed a little light on a subject that's going to affect not only our lives, our children's lives, and our grandchildren's lives into the future as to how we're going to cover this electrical need. Thanks for your attention. Have a great evening.